Hey guys, welcome to the April 2025 update for the go2hx compiler. This one's going to be a fun one, so without further ado, here we go. Version 0.2 is being released, and with it comes a lot of improvements from the contributor standpoint. So there's a code refactor, there's a lot of stability improvements, debugging support. You're able to now use the HXCPP compiler to build go2hx and, for instance, use the Tracy debugger. So there's a lot of really interesting stuff coming, and I'm extremely excited to show that off. Also, a big note is that because these things are now getting done, I heavily suspect that the speed at which development can take place for, be it for generics or other language features or quality of life stuff, it's just going to be faster. And I hope as well it can help some people if they're interested in contributing. Another thing I want to address is the current state of the compiler. A lot of people have been asking, okay, I see that there's all these changes and whatnot, or I see all these standard libraries, either they're working or not, but what does it actually mean in terms of am I able to use it? What am I able to use it on? So I just want to be straightforward and even a little bit simplistic on it. At the moment, it's the best possible time to do contributions to the project. As for early adopters, I think it's still very rough. If you're not at all interested in compilers or interested in making any type of contributions, it's going to be a really rough time because you're going to be stuck with a lot of stuff that simply doesn't work. So I'd say hold off. Next up is that the Go compiler is no longer a requirement to install go2hx. And so how that works is now we are going to set up the Go compiler on your behalf. And so you're no longer required to have one beforehand. And this is massive because now we don't have the same issue as we did of having a much harder onboarding process of finding an old, very specific Go version to use, and we can also shift the Go version easily without affecting users. The big change this the code refactoring, and this has been way too long to start it up, but I'm happy it's now emerged by the time you see this video. So the biggest thing is that the code base has outgrown its welcome. There's some parts of it that are just so insanely absurd. For instance, the typer, which deals with turning the Go AST into the Haxe AST, was 9,000 lines of code, which is just crazy. Now it's 176 lines of code, and it's broken up into 20 plus files. So it's just overall a much better experience. It's better for contributing. It's better for my sanity. There's just so many reasons, and it kind of feels silly now why I delayed so long, given just the results that have come from it, only for the past few days now. And yeah, I want to show off what it looks like. So without further ado, here's a demo. Okay, so demo time. This is the old master branch. I just kind of want to compare the two side by side to get an understanding of the reason why it's getting refactored, and then also comparison helps with just seeing the absolute drastic difference. So main, it's a little bit hectic. Main should really be just calling into something else, but as you can see, it's kind of grown into this giant spaghetti monster. It's not terrible, but it's a little bit all over the place, whereas the code refactoring version now has main, which calls compiler, and then compiler is able to hold a lot more of the abstraction in a better manner. So it has, for instance, events that you can see directly. It documents the steps at which, once it receives the data from the Go side of the compiler, what does it do with it? Oh, well, important. It takes the Go AST and does the Haxe AST transformations. If you try and do the same thing here, it's really not fun to try and figure out, okay, when does the AST transformations actually take place? It's it's a super big complication to try and figure that out, and it's not very readable. So big thing I wanted to do was make the code base more more human accessible. And I think I've achieved that. And the big potential way that I would not is if typer, for instance, was not refactored properly. So this is a 9,000 line file that handles almost everything to do with the go.ast transformation into Haxe.ast. And it's just the behemoth. It does everything and anything, and there is absolutely no structure, except some functions, but the functions can run for upwards of 300, 400 lines, and the nesting can get out of control where you're in 10 or 12 nests deep. So I really wanted to change that. I wanted to make it so, okay, if I want to make changes, I want to add generics, I want to add other language features, I want to, I don't know, check all these different things, make the code base able to last long term. I knew that I needed to fix the structure, and I pushed it off for the longest time for various reasons, but now it is in a much, much better state. So now it's 172 lines of code. It's been split into 20 plus files, and it actually has folders and structure based to it, and it's trying its best to be sensible in terms of the structure, how it works. You can, for instance, if you want to find how defer works in the system, here you go. If you want to figure out, okay, how does the range statement work? Okay, here you go. Oh, how does, I don't know, assign statements. I guess I'm only saying statements. What else? If you want to figure out binaries, for instance, which is an expression, here you go. It's so straightforward. Whereas before, you you might be able to look through and find it, right? Like if I look up binary, okay, I have all these different cases and I have to go and figure it out. I might not know that everything is followed with the prefix type binary, because if it's not the code base that I'm familiar with, then how am I supposed to know that? Whereas this is just, it's just human. It's human to be able to have the structure and the folders set up like this. So I'm extremely happy with this. I'm going to make it even better. Specifically, I'm going to get rid of info. We're going to get it parallelized. We're going to do really cool stuff with it. So that's that. On to the next demo. Okay, so on to one of my favorite new additions this month, which is the new patch system. So for those that don't know, the patch system is a way to add in handwritten Haxe code to fill in the gaps needed for the Go code compiled into Haxe code. So what that means in practicality is that, for instance, if you have an operating system call on the Go side, then that functionality needs to be met by the Haxe code. And so that can be, for instance, creating a file or sending something on the socket. So a good example is we have something like this. We have a file. We make a file, and then we have a defer that removes it later, and then we write to it. So the system that we had before is we have a giant map, and then we have an expression, a macro expression, and we just shove in all of the code. And that worked great for a few things, but it quickly ballooned into this massive endeavor of trying to shove everything into this single file. And it was just really, really impractical to continue to maintain it. So now, instead of that, we have actual files. And the amazing thing about it is, so for instance, I'll show you the create one. So you can see here, same exact functionalities in the patch. And also we can look at write file, and it's just Haxe code. It's Haxe code. It has the Haxe it has auto completion. We can see everything going. We can add even defines in. Everything works. It's wonderful. And the reason why it works so well is because of the genius work by Alex and Simon. Alex maintains and Simon first created the Haxe parse library, or the Haxe parser, and this allows Haxe. It's a library that allows Haxe code to be able to parse Haxe code and turn it into expressions. So it was really easy to set up, and I'm super, super grateful for the work that they've done to maintain it and to make it really, really good. And yeah, it it feels almost in the same way as the Haxe compiler can emit. So awesome work, really stable, and yeah, there's just so much stuff that you can do now with this. So this allows us to maintain a lot more code in a much more reasonable fashion. There's some syntax errors here, but these can be fixed. Overall, it's just such a delight to actually be able to make changes. If you want to add something in, you can just write in function, write in whatever the name is, and just add it in, and it will work. It's remarkable how easy it is, and yeah, it just makes it so contributing to the project will become so much easier because if, for instance, okay, maybe there's something missing in reflection. Okay, well, all I have to do is I have to go to scgo reflect, and this also follows the same pattern as the Haxe compiler. The Haxe compiler uses the same type of mechanic underneath where it has a bunch of targets, and then you have to define in that behavior for each one of the different targets. So for instance, file system, you have a C# implementation, C++ implementation, JavaScript implementation, etc. Well, JavaScript implementation if it's Haxe Node.js, but yeah, so that same behavior works, and likewise, we're doing the same exact thing in a little bit of a different way because the go2hx compilers are written in go2hx, not in OCaml. But yeah, it it has the same type of fundamental to it, and it works really, really well. And so I'm glad that we took the same type of paradigm, and yeah, it'll just make it so much easier to maintenance wise. So yeah, for instance, if there's some issue with, let's say deep equal, right? Okay, why is that happening? Oh, it's because of here. Okay, great. I can just make changes to it, and then I can just have it get recompiled. Awesome. I can see all the documentation. It's all laid out. Code completion will be here. You can even add new packages in that need to get that need to have the functionality added to it. It just works and it's brilliant. So, okay, final demo, short and sweet. This is called source file jumping or source jumping, something. And the use case is that a lot of the times when you're debugging the Go source code and you're seeing exactly what the issue is, why is the result not identical, you have Go source code and then you need to turn it into Haxe code and then you get the errors on the Haxe side, be it compile time or runtime, and that is great, but the issue is how do you track it back? And that can be a real challenge and it takes a long time. So now you can just simply jump to the locations. Now every single statement inside of a block, you get a little file URI and you can just click them with your ID and it'll jump you exactly to the location of that statement. And it's so incredibly useful, especially for big code bases, because a lot of the times the patterns can look the same and it can be really hard to figure out exactly where the locations are, and you have to track both the Go source code locations and the Haxe source code locations. And now you can just track errors straight back to the source of, okay, this switch statement is not correctly being transpiled. Fantastic. So there's that. Thanks for listening to the demos, and on now to the final part of the presentation. Okay, so now on to my favorite new addition to the compiler this month, the new Goroutine and channel system by Elliott. Now, this was talked about a little bit last month that IO was working, but it had some stability issues. And I think Elliott just heard that and decided, okay, I'm going to spearhead this. I'm going to fix all the issues. And he did. He blew my expectations away and he managed to rebuild the entire system from the ground up, go through, figure out how async tick and timers work and why certain parts of select doesn't work based on argument execution order and just all sorts of stuff, and just really got into it. And yeah, passed the tests. We have it merged now in the master, and the code quality is so much better off for it, and we have a much better foundation to build the Go routines and channels from. So thank you so much, Elliott. I'd like to thank all the contributors for April. Elliott Stoneham, of course, for his wonderful work this month. It's been absolutely a joy to work with you and to get your pull requests merged and go through all the tests and whatnot. So thank you so much for that. Also added myself, Joey, aka me. Managed to get a lot of things that I wanted done within the deadline that I set, which rarely happens, and also because the list is a little bit shorter than last month. So there's that. Also, I'd like to indirectly thank both Simon and Alex for their work on HaxParse and HaxParser, which is invaluable for getting the new patch system working. So thank you. Finally, thank you guys for watching. It's been a crazy journey thus far. The support and interest has been constant and steady, and it's been magnificent. So thank you guys so much for that. And if you're interested at all with the contribution side, looking into a Haxe compiler, maybe you have some ideas of how you want to use it, come join the Discord, come hang out, and yeah, on to next month. Cheers.